First off, this is just a teaser. We're going to do a whole larger presentation. We're actually going to do some actual measuring of the vehicle. So come into at the CIC meeting where we have actually part of a car coming in, and we'll do some actual live measurements down there. So I was introduced to this piece of equipment actually from Gary. Had told me about it at our last CIC meeting, and I was very skeptical, to say the least. How can you measure a car with a photograph? I mean, it's just not heard. And so I was really leery when I heard the pitch, and they sat there and they gave me all this, the hoopla about how this works. And I had the opportunity to go the next day to Gary's place and see this again. I was a little skeptical until we actually saw what it did. And so I want to get a little more involved with this. So I actually got some training from these people just to see what it was. And I'd like to just share some of the stuff I've had with this machine, and Gary can step in anytime. Some of the things here, again, I won't spend too much time on it, but datum is the measurement of your height. Center plane measures your width, and the zero plane measures your length. We'll talk about dimes, tolerances, we'll talk about that a little bit later, but plus or minus 3 on most vehicles today, some are 0. Next. So point-to-point measurements, this is where we're going to measure a tram gauge, go between 2 points, and just measure the length. We can measure only two direct dimensions, that's either length or width. We cannot measure height with a tram gauge or a tape measure. Next. So these would be point-to-point measurements. We just go across and just measure them. Some of the things that create a problem for us is that a lot of things aren't in a straight line, so we have a little bit of problem, and we have a lot of things in the engine compartment that, especially where most of this would take place, that gives us a lot of maybe a little bit different readings. Next. So here's some point-to-point measurements. Again, you can see on the spot one more. Where this car is actually swayed over a little bit. So this would come up here on a point-to-point measurement. What we needed was some way of doing three-dimensional measurements, so we started looking at three-dimensional. Next. So here's some of the various types. This would be a universal, this is a electromechanical, and that would be a jig system. These measure in three-dimensionality, length, width, and height all at one time. Next. A couple things about wheel alignments. If you view a car from the front and you look at the tilt inward out, that would be your camber. If you turn to the side, look at a wheel going from front to back, that's going to be your caster. Very important to understand these things. Next. I was in Hawaii with Dale, and we had this 2011 Honda on a global jig, and we were measuring the vehicle just to show you some of the damage here. Next. Again, next. We had an 8mm mash, which means we were 8 millimeters short on the length. The width had swayed over inward by 25 millimeters. Next. So you can see that here was the damage. This would only been available with this type of machine to see where it exactly was. One more. So we measured up some more, another dimension here from the top. You can see where the damage is. This car is swayed over to the one side. Next. Photograph, ladies and gentlemen. This is where it is. We measured point number 6 to point number 14, came out to 212. Point number 13 to its corner side was 1237 millimeters. A huge difference. Now that's just point-to-point measurements, but look where we did. Remember, point-to-points were 2 upper points. We went from an upper strut tower bolt to a frame rail. Look at the difference. How are you going to do that with a tape measure or a tram gauge? It's impossible. But in the photograph, it's able to do this. So, they pulled the car. You can see everything's lined up. Again. So we're back to original specifications. And look at this, 758 and 758. Just 2 dimensions. Car straight. Photograph. Next. Again, these are some of the matrix studies. Not just two-dimensionality. We have the ability to take this machine and convert it over to where we have three-dimensionality. So we can measure length, width, and height with a photograph now. Next. We can go underneath the car. We can measure suspension. We can measure cross members. We can measure movement of the cross members. Next. Some more pictures. We can measure door openings. We can measure the B pillars moving in and out, which, again, with these new metals and energy transfer of all this ultra-high strength steels, unless you're literally measuring those cars, you don't know how much movement has occurred. That's why it's so important to measure these vehicles prior to starting working on them. But we don't do that as an industry. We're going to have to change it, ladies and gentlemen. Next. So here are some of the dimensions where as you can see, we talked about the width. You can see where the damage has occurred. Next. Where is this done? This is not to replace a measuring system. Understand that. This is a supplement to a measuring system. This is where we do in the blueprint. Gives us that information up front prior to us working on the vehicles. If we have this information up front, we can write a more accurate estimate. We can start to look at having to stop these people running back and forth and get up. We know exactly where that damage is. And it's done with a photograph. And again, we'll leave the amount how long it takes to you can watch how it's actually done. But you can see, it eliminates the structural guesswork. We get a printed documentation, more complete structural repairs, better accurate estimates in the blueprint, reduced supplements, lower friction costs. All of these things with a photograph.
Can I have a point there?
Your turn.
How often do you see the car come into the store and you look at it and say, that ought to be worth 2 hours or 12 hours or whatever it makes pull, to find out later when you begin the repair process that, oops, it was a little more than what you anticipated. Some of us are going to go ahead and go back to the carrier. Some of us are going to accept it and, hey, dude, it's what it is. Get it done. Boom. It's all taken care of. This eliminates that. Literally, you take the time to go ahead and perform this in your upfront blueprinting process. It's done. You've got the data, and the carriers so far that we've used, or the carriers that's come in our store, they've embraced it. It's a terrific tool. It shows them no ifs, ands, or buts where we are from a structural standpoint. Now it doesn't do like I said, it's more of a comparative measuring type tool, but it's enough there to get us an opportunity right there up front what it's going to take to repair it. And then predictive wheel alignments. How often do you drive, you're in that last day, you got everything ready, and now you go test drive the car and you feel that little pull. And now you got to call the wheel alignment place or hopefully get into line with your wheel alignment machine or whatever scenario is. You catch it up front. Do a predictive wheel alignment analysis on it and you have it. Now, and there isn't a question as to, well, are you sure? Well, yeah, here's the data. How would anybody do that? So anyway, it's an incredible tool to use specifically when you're really trying to get into that blueprinting process. If you really want to get the negotiated process up front, you want to take care of the days that you're going to lose by not having all this data up front, this is a tool to do it.
A couple final notes is that this can be done anywhere in your facility. This doesn't have to be in the body shop, it can be out in front of the store, it can be anywhere in the facility, as long as you have a place where you can photograph it. And this is something that is mind-boggling. I think it's good, as I put in my article, it's a game changer. We'll talk a lot more in detail in the afternoon session. Any questions?